Hello everyone, this is Wilson. Today I'm going to talk about this limit problem here. It's a limit problem that involves an absolute value around the variable x. And when x is approaching 0, as you can see here, we are getting an indeterminate form of 0 over 0, so we have no idea what this quantity is approaching to, even though we know that this quantity, this is a 5, right? We are adding some quantity to the 5. And we try to figure out what happens to this absolute value of x over x when x is approaching 0. Okay, so we are going to start by thinking about what happens when x is approaching 0. So first thing is that when x is approaching 0, um, it can approach 0 from the right side and approach 0 from the left side. If x is approaching 0 from the right side, then you know that all those values that you take to approach 0 would be positive. But on the other hand, if x is approaching 0 from the left side, then what happens is that all those values that you take when you let x approach 0 from the left side will be negative. And so in this case, when you take the absolute value, it does make a difference on whether you are approaching 0 from the right and whether you're approaching 0 from the left. So we are going to consider the one-sided limit for this function. So first, we are going to consider that when x is approaching 0 from the left side, what happens to the function? What is the function approaching to? So we are going to consider this one right here. And so what happens is that when x is approaching 0, as you can see here from the left side, then x would be negative. And when x is negative, then what happens to the absolute value of x? Let's just recall something right here. So we know that the absolute value of x is equal to x when x is greater than or equal to 0, and the absolute value of x is equal to negative x when x is negative, when x is less than 0. Okay, so now since x is less than 0, when we can actually rewrite this absolute value as negative x. And so now the limit actually becomes, oops, so it should be minus, right? So it'd be approaching 0 from the left. Then it would be 5 plus, and then now this absolute value of x will become negative x. So we are going to put the negative x right here. Okay, so now as you can see, we can actually simplify this expression right here by dividing top and the bottom by the x. Because when x is approaching 0, it's not actually equal to 0, so we can divide by a non-zero quantity. And so we actually have, if we are canceling them, then what happens? What are we getting here? We are actually getting, what is that? That's going to be negative 1. So we are actually getting 5 minus 1. And so that's actually just equal to 4. Okay, so the one-sided limit when x is approaching 0 from the left exists, and it's equal to 4. Now we need to consider the other one-sided limit when x is approaching 0 from the right. So let's look at that. So we are going to look at this one here. And then the function stays the same. And so as you can see here, when x is approaching 0 from the left side, x is negative. But when x is approaching 0 from the right side, then x is positive. And do you see what's going on here when we look at that? Then we have 5 and then now plus. Now we need to think about what goes in the numerator of this fraction. So when x is positive, then absolute value x can be written as just x, right? Without the absolute value, so we can just put the x right here. Okay, so now doing the canceling like the other limit, then we are actually just getting 1 here and 1 here. And then now just continuing with the problem. So we have x approaching 0 from the right, and then we have what is that, 5, and then plus 1. Then as you can see here, the limit is equal to 6. So what happened is that the function is approaching to 4 when x is approaching 0 from the left, and the function is approaching to 6 when x is approaching 0 from the right. And so as you can see here, because the left side limit is not equal to the right side limit. Okay, so now we'll say that since the left side limit the function is not equal to the right side limit, we say that the two-sided limit, right, this one, which is our original limit problem, does not exist because the left side limit is not equal to the right side limit. Okay, so that's it for this problem. If you like this video, please give me a thumb up, subscribe to my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. Thank you for watching this video.